Okay. So, hi, I'm Arnar from Fab Lab Reykjavik, and I'm the technical representative there. And first off, I'd like to show some just photos of what I've been doing lately and what I've been 3D printing and what my experience is. So, let me see here. And kind of goes, here are a couple of pictures. This is from Have, my coworker, and you can see over there how to bolt up the cords up to the ceiling. That's 3D printed, and I'm just gonna go quite fast over these pictures just to show you what we have at our lab and what's my experience with 3D printing. So that's out of the way. 3D printing A to Ö. First off, we need a 3D file, and the most common files for 3D printing are STL, OBJ, and 3MF. The most common one is STL, and then it just depends on what software you're using to get the file, and most of the times they support STL, but some other software only offer OBJ. And now 3MF is getting quite common, especially for the slicers that manipulate the model to export the code for the machine. And you can say, at least in Cura and Prusa Slicer, you can save it as a project, and it saves all the settings you set up for each print. So if you're working on another computer and you're configuring every setting, you can save it as a project. Then you can open it at another computer, another location, and then all the settings are done. And also you can send the file out to a manufacturer, so you can get the precise print that you need. To begin with, we have different kinds of 3D printers, and the most common ones are FDM. They're really, really common. And looking at the future, I predict that at least DLP printers will be more and more common. And SLA as well. It depends on how each printer prints. And especially with DLP, it's a digital light panel, and it can do one layer at a time instead of going with a UV light and making a line to harden all the materials. And so you can print out multiple items in one print at the same speed as a single piece. And just keep an eye out for these, but I will talk only about FDMs because I've only had experience on those. So the plastic that we use is mostly PLA, polylactic acid. And in the link here, there is an article of impact of corn-based plastics and how to dispose of it, how we can reuse it, and how it affects the environment. And especially when we're talking about pollution and the plastic going into the sea and sort of stuff. So it's really good to get to know at least it's good to understand how to dispose of the plastic at where you are. So like with PLA, it's corn-based, and it's biodegradable at a certain point. If it goes into a landfill, it will biodegrade in about 300 and up to 1,000 years. But you would preferably have to dispose of it in a controlled environment to get it correctly recycled. With ABS, that's quite common as well, but that material is made with oil, and it depends on each material how it's made. And I have to do a little bit more research on that, and I think Daði has some experience in that since he has been working with precious plastic, and I will just have to have a talk with him later on, and I would recommend just look a little bit into it. And I think later on, by the end of the week, I'll have a couple of links on what the material is made of and how to dispose of it. Then we have TPU, which is tetrapolyurethane, and which is an elastic filament. And as you can see here, the watch band that I have, if you can see it, I can also show you a photo here. This one, the watch band that I made is from TPU, and it's flexible and it works really well for my watch. And now I have to find my mouse again. There it is. And then we have the PVA. PVA is mostly used if you have a two-headed 3D printer. So if you have dual extrusion. PVA is the same as all the glue sticks that you have, and it dissolves in water. So you would have to, it is used as a support material. So I will go a little bit into that because if you are printing at a certain angle or at printing in mid-air, you need to have something underneath it to support the plastic that you're printing in. And now if we go to how it operates, with a filament, it is basically like a hot glue gun, but instead of hot glue, it's using plastic to melt it, and it uses the motor to feed it and move it around to make it into a certain shape. And it will go one layer at a time, so it goes from the bottom to the top. And here you can see, if we're talking about the form, what you have to have in mind when you're designing is mostly how it's formed and how it's gonna print, and if you need to take it a little bit apart, like cut it in half and print it in multiple pieces. And the next step is one of the most common question, and it ranges from everything, is time. 3D printing takes time, but everything depends on how the form, the shape of the form, and also on the settings. As you can see on this 3D print here, I can also have a closer look, is the black one took 6 hours and the white one took about 40 minutes. And it's the same print. As you can see on the face and on each layer, the white one is 0.2, the black one is 0.06, and also I used PVA as a support for the mid-air extrusion and the overhangs.
Sorry, how big are the pieces? Like
Um,
it's tight
they,
or
the base is 25 millimeters, so it's about 5 centimeters. Yeah, about. They are
okay,
really small.
very
It's
nice.
like the size of your thumb, mostly. So that is the most common question and most difficult question to answer is how long does it take? It all depends on everything, and that's what we're going to go into now, is the slicer. So you have your settings, and everything depends on the layer height, the shells, infill, print speed, the support. I also have in there build plate adhesion, but that doesn't affect the time. It mostly affects the beginning of the print, and I can go a little bit into that and show you a little bit on the software itself. Forgot to put it. Take a second. And also about time. You can see in the slicer itself how long each print is going to take. So you don't have to make guesswork of how long. Showing up, yep. Okay. So here, oh, there's an update. Cool. I'm not going to do that now. So to begin with, we have different printers, and if you go here and manage printers, you can add different kinds of printers, but the most common ones are Ultimaker 3, at least with the Fab Labs here, or Ultimaker 2. But if you have a certain printer, I would recommend looking it up. And we have Prusa 3D in our lab, the Prusa i3 Mark III as well. So there are different kind of, each printer receives most of the time different kinds of codes. So it does matter which printer you're operating in the software. So here you have, you can select each material, generic, ABS, and so on. And we're just gonna do that and see if we have any files. Yeah, we can just, I don't think that's the best example, but yeah, it should be fine. And here are most of the settings. To begin with, I would recommend just going here and just to print a single thing, maybe a test piece or something, and see how it comes out just with these settings. And then if you go into custom, then you have a whole range of different kind of settings. If you go into quality and if you see the cog on the right there on each settings, you have different kind of stuff. So basic, advanced, expert. I would recommend advanced at least, because basic is almost the same as earlier. But I tend to check all because I like to see different kind of statistics. And here you can see each configuration of everything. And one good thing is when you hover over each text, you can see what it's going to do and how it affects the print itself. And if I'm going to do something really, really quick, I could just set it to 0.2 and change the shells and so on. I'm just going to go through each and most of the common settings that we're going to use. So quality, you can see 0.2, and if I put it to something the printer is uncomfortable with, it displays as an orange, and also it displays as a red if it's impossible. But get to know your 3D printer, how big the extruder is, and then you can see the limits of the printer. And with quality, at least with the Ultimate 3, I can go as far as 0.04. And that is then it's going to take a long time to do. And then shells, this might affect large prints on how long it takes. And most of the times I just set it to two wall line counts, and most of the time it's enough, especially if it's mostly just a display piece that is not going to be like some kind of friction or needs to have some strength in it. And you can always up the count if it's going to do something. But if you want to save time, at least for prototyping, make it quicker, then I would recommend wall line count 2. And there's also different kind of settings on here, and I just recommend look just a little bit over it. Then we have the infill. The normal is set to 20, but I always put it into 10 because most of the times the infill strength doesn't change that much. The only time you have to increase it most of the times is when you go into preview and you see there is no infill in certain parts of the print. And what's it called? The strength, if I have it at 10% and then I put it to let's say about 50%, the real strength goes up a couple of percents, at least from what I've seen from different kind of videos. And then you have here different types of infill patterns. One of the strongest ones are triangles, and there are different types here, which is most of the times more aesthetic than other. And if you want to have something like with a transparent plastic, then it will be really cool sometimes. But if you're going for strength, I would recommend triangles, at least with Cura. And then there are different types of stuff here. I don't go into more here. Let's see. And if you have a dual extruder, you can put the the other filament into the infill, but I've never done that. Then we have the material. Most of PLA melts down in 205 degrees. Depends on each material. So I would recommend checking the spool and the box as well. And the heat affects also with PLA. It affects the shininess of the print, at least from what I've seen. And also you can see here the flow of the material, and that might be like if the printer is over extruding or under extruding, you might want to configure that a little bit when you do like a test print with, let's say, a 10 millimeter cube on all sides. So, and you measure that and it's not doing that completely 100% 10 millimeters, you might want to change the flow of the printer because it might be under extruding or over extruding. And it also depends on the material that you're using. So keep that in mind. It's not the printer most of the time that is affecting this, it's the filament. And also if you have a build plate that has a heater bed, a printer with a heater bed, you can set the temperature here. For instance, if I were to use ABS or like a thermoplastic, filament. I would set it up to about 100, up to 120. Depends if your printer can keep up with it. And also, so you can put here, like at the beginning, where it's printing, how the flow is going, and different kind of setting. And there's not more with the material. Then it's the speed. The speed affects on the horizontal, what's it called, detail. And you can try to up it a little bit. I mostly, with my printer, I put it up to 90. 70 is really good. And you can also make it a lot slower, like with the black guy that I showed you earlier. He was also a little bit slower, so the horizontal detail popped up a little bit more. And then you can set the speed and everything. And here is really good with the initial layer speed. That affects how good it's gonna adhere to the build plate. And if you go too fast, it might not stick to it, and so on. Then with traveling, sometimes it does different types of stuff. So it might like bump into the support when it's traveling and knock it over and so on. So it just depends on the material, the print itself, how it's gonna go, and if it's gonna, then you can make it go up before it's traveling somewhere, so it doesn't knock some prints over. Then we have cooling. This might affect at least the beginning of your print. As you can see, initial fan speed, so when it's printing the first layers, it's set to 0%, so it manages to adhere to the bed really well. And here you can have different kind of settings, so if your print is warping, you might need to change this. And also when it's printing, you can change the fan speed, so you might have some different effects for your print. Now with support, we're just gonna put here general support. You have here you have support overhang angle. I would recommend testing a overhang test on your printer to see the limits of how far it will go before it affects the result of the print itself. What I've seen with my Ultimaker is 60 degrees is fine. When it goes more than that, it starts to have a overhang in it. But with a Prusa 70, where 65 is really good, and it's affecting the 70 just a little bit. And then you have the zigzag and the pattern of it, and most of the time you can just see it with the preview. Might go into that a little bit later. And then you have support placement. That might help out a little bit with some types of prints. So you can select touching build plates or everywhere. But that is a really niche setting that I've had to use maybe once. And also, if we have a dual extruder, you can put the PVA as a support, or you can put what's called breakaway material. I still have to test that, but I have had good results with the PVA. And so it's using the other material. You can also use different types of plastic as a support if you have dual extrusion. Then you have the support density, and now there's one interesting thing with the support here is enable support roof. And if you're printing, let's say if you're printing out the earth, you want the detail all around the globe. So you might want to print it half and half, but if you want to print it all at once, you want the detail at the bottom. So what the support, I think, is the floor or the roof. It's gonna make like a really nice surface for the plastic to print on. So instead of making just straight lines, as we will see just in a little bit. And that's mostly for that. Then we have the build plate adhesion, and we have skirt, brim, and raft, and none. I mostly use brim, at least if I have a really good heated bed. And I haven't had to have raft in a long time since we stopped using one of the older printers. And we'll just see in a bit what everything does with a preview. So that is mostly all is what's here, but I can show you a little bit now with everything. With a benchy, that is, let's see, then we can see. If I go here and press slice, now I can actually see the correct time of the print. And let's see, up here is color scheme and light type. A line type. You can have material color, but I mostly use line type because now I can see the support, the shell, and the infill, and I can check and uncheck everything that's in there. So I can identify what if there is something, if something is going to go wrong with the print. For instance, I've seen with some prints where I go here and I would see it's skipping like 1 or 2 layers. Then I know there's something wrong with the 3D file and the print would fail automatically. So always check the preview, see how it's going to print. Even though you're doing it quite fast, just go from top to bottom and see how it's going to print. And if we take the support off, I can show you what the different types of build plate adhesion does. So now you can see here with the blue thing here is the brim of the build plate adhesion, and when plastic cools down, it tends to shrink. So then you would have something called warping happening to you, and you can change the width here of it. So most of the times I have it maybe about 3 millimeters or so wide. But let's see, just with a raft, it's kind of self-explanatory. What's it going to do? It's going to create a raft, but how it looks is quite different from the brim. It's gonna create a raft underneath it. So if I click here and use the arrow keys, I can go 1 up and so on. And now I can see exactly what it's going to do. And now I see this is what it's printing, and I do not use it unless it's like really special cases. And the bottom of the print, when it does this, I don't find it that fancy. It's not completely smooth, so just it always depends on each and everything. Now if I go to skirts, it's just gonna create about 1 or 2 lines around the print itself. And if you want to save a little bit, just a couple of minutes time, you can have this if you don't want to peel off the adhesion. And now we can see if we go take off the helpers and the shell, you can see here this is how the infill looks. And let's just have the shell as well and see how the print is going to go. So I can see mostly the strength of each part in here. So if I were to want to have a little bit more strength in the material, then I would want to change the infill percentage or how the pattern of it. And mostly if you look here is no infill, so I might want to change that to have some strength in there. So I would maybe put in, let's see what the grid does and how it's going to look. This is this is what you're going to do mostly with 3D printing to see what it's going to do. And as you can see here, this is mostly fine. I'm perfectly good with that. And then I would just save to file and save it and put it in the 3D printer. Now, after we've done that, now it starts printing. And what might happen during a print is these types of stuff. And then we have a really good, there is a really good website to troubleshoot each print. And let's say at the beginning, it's not extruding at the start of the print. So you just click here and then common solution. And you really just over this, and you might want to change something with the print or the printer itself. And there's also a couple of things you can do while it's printing. What I have tended to do is use kennarartyggju. Kennarartyggju.
Feature scum.
Yeah, it's like a really sticky clay that is not
stickish.
Yeah. I've used that for when it's printing one of the first layers and you see what's called warping. That is most of the time here, warping at the beginning of the print. Oh, okay, yeah.
How do you use it with the warping? Like just
at least if it has a brim, then I just put it at the brim, and the sticky thingy doesn't affect the print itself. I used it just yesterday to fix it at the beginning of the print, so I wouldn't have to completely.
Is it strong enough?
Again. Yeah.
Like, is it that strong to hold it down? Okay.
Yeah. And even though the print head went over the sticky thingy, it printed out really nicely. And also, what you tend to have with, let's see, if we put the support on, if the support itself is gonna fall, if it falls mid-print, you can pause it and take the sticky thingy and put it back to the other supports or the form itself, and then you might want it, then you can continue. So it might be a little bit offset, but you can it will correct itself in the end. So if we go to here and let's see, let's say for instance, this here is very likely to fall off because there's nothing holding on to it. So here I would have to have the brim, but if I were to print it like so, and this falls off mid-print, I can put the sticky thing in here between to hold this in place, and it would just print on here and so on. So you don't really have to abort the print itself right away. You can try to do it mid-print or stop it and then continue on. And yeah, that is my experience with with troubleshooting while it's printing, and I've mostly done it with something like this. Let's say, for instance, and now I'm going to go into the PVA, the dissolvable filament. I go here, and this is quite common that it's gonna expand horizontal. Like as you can see, it's gonna go too wide to the sides when it's gonna print, and it's gonna take too much time and so on. So I have somewhere, if you just go here for horizontal expansion, and I can put this up to 1 or 0, so it's not gonna go too much to the sides. And I have, this has helped me a little bit with the printing. And also you can see here, exactly here, how the support, the PVA is gonna make like a really good floor for the print to print on. As I was talking about with the settings before, the PVA does it automatically. So when it's gonna print the plastic, it's gonna make a really smooth surface underneath the print. Because if you have the regular support, you might get a little bit overhang and so on. So if you're trying to get a really smooth finish from both sides, I would recommend that. And if we go back, I can find my mouse. Yeah. And these aren't that common of a mistakes, at least with the Ultimakers, but I always keep in mind, what can you learn from each print? And now is the post-processing. So what you need to think about is, what is the function of the print? Is it gonna go straight into what you're doing? Is it gonna or is it more of a display thing? Do you need to sand it or put spray on it and sand and so on? And there are different types of post-processing that I've done, at least with PLA, because you cannot acetone smooth it. Is I put plaster on it and then sand that down, and then I would spray it with a primer. Doesn't matter what type of primer it is, especially if it's easy to sand down, because the plastic itself is quite hard to sand down. And let's see. Yeah, and that's most of it. So if there are any questions, please feel free to ask them. Oh yeah, Fab Lab mentioned a little bit. And now I'm gonna go into a little bit like with research. One YouTuber that I would recommend checking out is CNC Kitchen. He is really good if you're trying to decide on which plastic, infill, or different types of stuff. If you like what you're going to decide. Like here, he has which layer height gives you the strongest 3D prints, and he has like a graph over different types of methods. So he has somewhat of a scientific experiment on how he's testing all the materials. So it's like pulling from top to bottom, and it also depends on how it is printed. So here it is printed horizontal, and you can see the strength of each material, see the strength of each print, like with the layers. And I highly recommend him. Then here's a little bit on recycling your failed 3D prints and the support, but this is more of a niche thing, so you would have to buy or make a filament maker. So it is an interesting thing. And here is also one of the things that I've made is like with the PVA. This is the 3D print that took about 1 day and 18 hours, and it's about 30 centimeters tall. And
what was the layer height?
0.2, and it was 90 millimeter per second speed, 10% infill, and 2 shells. I upped the speed as much as I could, and as I was comfortable with. I could have done it a little bit faster, but then I would sacrifice the end result of the print. Then I have here the Pva Supports Resolvement, so you can see how it reacts when it's dissolving. And it took me it takes about 24 hours to completely dissolve. So at the beginning it was quite much, but after the first 10 seconds of this video, you can see mostly on here and in the armpits, there's still some PVA left, so you would have to wait quite long, at least with the PVA that Ultimaker makes. It might differ from each manufacturer, so you might have to add salt water, or I've heard citrus has helped make it dissolve. And also with about PVA and recycling, from what I've read, you can dispose of it in the sink. But they recommend consulting your disposal waste management to see is it safe? Is it good to dispose of it in the sink? And it doesn't affect the life, the sea life, like fishes and so on. At least from what I've read, I cannot confirm. And here's also one thing with post-processing is if you want to have like screws in the 3D print, it's quite easy to make threads in the plastic itself, but you can also insert different kind of brass threading in there, which hold really, really well. And damn advertisement. And I
don't trust that person.
I do not. And as you can see, just in a second. Here is different type of threaded inserts. So, and with no threaded inserts, it is quite strong. But if you're going for like try to have it stronger than you, as strong as you can, then you might want to have like more high quality brass inserts. But as you can, and it just uses a soldering iron to heat it up. And let me see, because the 3D printer itself can make print out a threaded hole, and you can also use a like a tap or whatever it's called to clean out the thread. And yeah, that's most. And also, if you're gonna paint the material, it's most likely to go off with some friction. So if it's a display piece or like a miniature or some sort, you might want to coat it with something. So if you're handling the material itself, it might come off quite easily. But it depends on the plastic that you're going to use. And yeah, that is, I think, everything from me that I can rant about.
Awesome. Yeah, those look really nice. Did you 3D design those yourself?
No.
What is it called? Hair?